Hello everyone, welcome back. In this video we're going to solve an example on calculating theoretical density. Now before diving into the solution, let's explain what do we need in order to calculate density here. So the equation that we explained there, there is n number of atoms. There is the unit weight, Na Avogadro number, and Vc volume of unit cell. Now let's say this is what we want to calculate density. But in order to calculate density, we need to have 4 variables. Now Na is constant, no problem at all. Na constant, doesn't matter which element you have, it's still Na. So it means that if you want to calculate theoretical density, you need the element. Why? Because in order to get A, which is atomic weight, we need element. So if I don't know the element, I don't know atomic weight. So in order to calculate theoretical density, the first thing we have to know the element. This is one, which is going to give me A. So for N and Vc, what do we need? We need the crystal structure here. Why? N is number of atom, and Vc stands for unit cell volume. Now in previous videos or sessions, we calculated volume of unit cell based on the crystal structure. Remember, if it's cubic, you'll say A cube. But A has a relation with R, the radius of element, the atom, and that one depends on the crystal structure. So in order to have N and Vc, both of them, we need the crystal structure. So here we need the crystal structure. So if I have the crystal structure, let's say if it is an example, if it is FCC, I know N, small n, which is the number of atoms will be 4, and I know the Vc is going to be A cube, but I have something else. I know that A has a relation with R, which we know A is equal to 2 root 2R. Then from the element, what do I get? I will get A, which is the atomic weight, and atomic radius as well. I'll get the two of them. Why? Because atomic weight and the radius, because if I know the elements, we can use that table. We're going to use it in a bit. We can get the radius and the atomic weight. I have those two. From the crystal structure, when I say FCC, I got N to be 4 atoms in the crystal structure. The volume, it's cubic FCC, cubic crystal structure. So volume of the unit cell is A cube, and A has a relation with R, which is 2 root 2 R. This is how we're going to use this equation. So we have to look for those information, the element and the crystal structure, in order to calculate the density. So we have to know the element is going to give us what, and the crystal structure is going to give us what. Now, let's check this example here, simple one. It says kappa has an atomic radius. So first is kappa, the element, atomic radius is 0.128 nanometer, and FCC crystal structure, an atomic weight of 63.5 gram per mole. Compute the theoretical density and compare the answer with its measured density. Well, the information given to me, it tells me it's FCC crystal structure, so it's going to give me N and the volume of the unit cell. Well, by knowing the elements, we know what the radius and the atomic weight, both of them are related to what? To this guy, kappa. So since we know kappa, this is the two information that we got. Let's say those are not given. Those two information are not given. The atomic weight and radius is not given. We're going to go to the table that we will share this table as well. We'll look for kappa. We'll just kappa here. We have atomic weight 63.55, and then we have atomic radius 0.128. We're not going to go for ionic radius. We need the atomic radius here. Do not mix them. We'll look for the atomic radius. So we'll come back there. We'll see that this is what we have there. This is 5,5 as well. And the crystal structure, FCC, is going to give us N and VC. So, well, the solution is here, but I'm just gonna explain it on the board together to see how we're dealing with it. Now, we'll go for the density equation. It's equal to N A over, excuse me, so we have NA A. Here we have VC. It's a bit slow, so please forgive me for the handwriting. This is quite challenging. Even to write with the pen, I'm struggling. So NA, which is the Avogadro number. Now, because it's FCC, we know that N is going to be 4. N is going to be 4 atoms because of FCC. Look, I'm saying because of FCC, N is equal to 4. VC is equal to A cube, and we know that if A cube, and we know that A is equal to 2 root 2R. 2 root 2R. Now cube this one. You're going to get this one somewhere. I'm going to talk about the units to see how does it work here. Now, on the other side, A, we know it because of the kappa. We have 63.5. So the unit for this one, it's gram per mole. This is gram per mole. The Avogadro number, it's atoms per mole. So we know this one as well. The unit for Avogadro number goes, this is 23, goes for atoms per mole. Atoms per mole. Well, this is we call 4 atoms, yes? 4 atoms. Now the volume of unit cell units, or the units of volume, will be what? Depends on the R, and we know R here is given to us to be 0.128 nanometer. Now, if I calculate A cube, will be nanometer cube. Nanometer cube. Now, what do you expect the density of elements they're providing in the table? So in the table, they provide the density of elements as a gram per centimeter cube. They're representing gram per centimeter cube. Now, let's see where this unit came from. You see that the gram is here. Yes, this is what I'm looking for. This guy will stay to the end. Now the mole, both of them at the bottom, this small cancelling this small here, the atoms here cancelling the atoms here. So you realize that at the top, the atomic weight gives us the gram, and the volume is going to give us the unit at the bottom. But this unit is nanometer, 0.128 nanometer. So I can change this one to centimeter, then calculate volume. The volume will be centimeter cube. If you want to change nanometer to centimeter, you will do what? You will multiply it by 10 to the power minus 7. So if I multiply this one by 10 to the power minus 7, I'm converting it to centimeter. So it is something like this, will be centimeter over nanometer. So the nanometer with nanometer will go, the result will be in centimeter. Then when you calculate A and cube it, the result will be centimeter cube. Remember, units are important. If you don't know how to deal with units, then the result will not be correct. Now it's clear the gram here from the atomic weight comes, and the volume is deciding the bottom part of the density, which is centimeter cube here. Mainly within the textbooks, density goes with gram per centimeter cube for the elements. Now I hope that calculating this one will not be a problem. Let's just show it to you on the, it's already there to see. I wrote it here. So they're writing this with 4 atoms per unit cell. Yeah, sometimes they write these unit cells here because it's for 1 unit cell. Now, okay, they changed this ones. Once the student asked why they multiplied by minus 8 here, they changed it to 1.28. 1.28. Let me just zoom a bit. And instead of writing point 0.1, because the radius is given to be 1.128. I mean, this is in centimeter. We said 10 to the power minus 7 is in centimeter. I mean, it appeared to be minus 8 here. Why? Because they put this dot here, so it increased one of the digits. Now it became 1.28. Yeah, it's totally fine. You can write it like this, 10 to the power minus 8. 10 to the power minus 8. That's possible. Even you can make it 12.8 10 to the power minus 9. Or 128 10 to the power minus 10. That's also possible. So, okay, this is the cube for that side. And then this is the volume. It's here. It will be cube the volume, and then multiply by Avogadro number, and this is the atomic weight, and you will get a density 8.89 gram centimeter cube. Now this is theoretical calculation for kappa 8.89, and we shall check with the measured, which we called the measured one for kappa is 8.94. 8.94 is the actual one density of solid. It's been calculated, measured, and theoretically we calculated as to be 8.89. Yeah, there is difference between them, but they're close to each other. This is how we're calculating density, theoretical density, based on what? Knowing the crystal structure and knowing the element. By knowing the crystal structure, what do we know? We know the number of atoms per unit cell, and we can calculate the volume of unit cell. Then by knowing the elements, we know the atomic weight, and we know the radius of atom that will be used inside the calculation for the volume. In the next video, we'll explain how we use the density to calculate some other things. But we'll be still using the same equation, but we'll just rearrange them according to what we want. Thanks for watching.